everyone, this is Teacher Abby, and for today's video, we're going to talk about remainder theorem and factor theorem. And the objectives for today's lessons are prove the remainder and factor theorems, find the remainder using synthetic division or the remainder theorem, and solve word problems using remainder and factor theorem. Since we are done with the objectives, and now let us move on with our simple activity. This drill is to substitute the value of x to the given polynomial equation in order to solve for the value of y. Number 1, y is equal to 2x raised to 3 minus 5x squared plus 3x plus 7, wherein x is equal to negative 1. And for number 2, y is equal to x raised to 4 minus 10x squared minus 2x plus 4, wherein x is equal to 2. Now, I am going to give you 3 minutes to answer this one. Since we are already done with our activity and you're able to answer it correctly, now we are proceeding to the definition of terms. Let us have the first theorem, which is the remainder theorem. The remainder theorem states that if the polynomial p of x is divided by x minus r, then the remainder r is a constant and is equal to p of r. So as you can see, in this, p of x is our dividend, while x minus r is our divisor. When we substitute the value of r to the value of x, we can arrive to p of r, which is same with the value of our remainder as we divide the dividend p of x by the divisor x minus r. So that will be r is equal to p of r. Thus, there are two ways to find the remainder when p of x is divided by x minus r. That is 1. Using synthetic division. 2 is to calculate p of r. To further understand what is the remainder theorem all about, let us have the example number 1. For example number 1, find the remainder of 6x squared minus 2x plus 1 divided by x plus 2. Using remainder theorem, we need to get the value of our r, wherein we're going to equate x plus 2, the divisor, equal to 0. As we equate the x plus 2 equal to 0, we're going to able to get the value of x, which is equal to negative 2. Then, since we have the value of x, we can already substitute the x to the excess of our dividend, which is 6x squared minus 2x plus 1, and the excess here will be replaced by negative 2. So that will be p of negative 2 equal to 6. Our x will be replaced by negative 2 raised to 2 minus 2, again replaced by negative 2 plus 1. From here, we can already simplify this one with the exponent first, which is negative 2 raised to 2, which will be negative 2 times negative 2, that is equal to 4. And so as to negative 2 times negative 2, which is equal to 4 also. So that will be 6 is times negative sign times 4 rather, plus 4 plus 1, which is 6 times 4 is equal to 24, and 24 plus 4 is 28 plus 1, and that will be equal to 29. Therefore, our remainder will be equal to 29. Now, let us see if the value of our remainder under remainder theorem is the same with the second method of getting remainder, which is synthetic division. So, if you're going to remember to our last topic, we always get the value of our divisor, which is x plus 2 will be equal to negative 2. Then the numerical coefficients of the dividend, which is 6, negative 2, and 1. Then, we always bring down the first numerical coefficient down, which is 6. Then, we're going to multiply this one to the negative 2, which is 6 times negative 2 will be negative 12. Then, we're going to add this one, negative 2 plus negative 12, that will be negative 14. Negative 14 times negative 2, that will be positive 28. And 1 plus 28 is 29. So, as you can see, we have arrived at the same value of remainder, which is 29. Therefore, the remainder of p of x is equal to 6x squared minus 2x plus 1 divided by x plus 2 is 29. And for our second example, we have find the remainder of x raised to 4 minus 3x squared plus 2 divided by x minus 4. Again, using the remainder theorem, we need to get the value of r from the r divisor. In order to get the value of r, we need to equate the divisor by x minus 4 equal to 0, wherein we are able to get the value of x, which is equal to 4. Now, since we have the value of x, we can substitute it from our dividend, which is x raised to 4 minus 3x squared plus 2. And replacing the x's by 4, that will be p of 4 is equal to 4 raised to 4 minus 3 times 4 raised to 2 plus 2. And now, let us simplify this by simplifying the exponent by 4 raised to 4, which is equal to 256, and 4 raised to 2 is 16. And now, let us simplify 3 times 16, which is equal to 48. 256 minus 48 is equal to what? Okay, then add 2, that will be equal to 210. Now, let us compare if the remainder under the synthetic division method will be same as the remainder theorem, which is 210. So again, using synthetic division, the divisor would be equal to 4. Then the numerical coefficient would be 1. Since we have missing term here, we will put 0. Then followed by negative 3. Then another missing term, which is 0 also. Then the constant, which is 2. Now let us bring down the first numerical coefficient, which is 1. Then 1 times 4, that is 4. 0 plus 4, that is 4. 4 times 4, that is 16. Negative 3 plus 16, that is 13. 13 times 4, that is 52. 0 plus 52, 52. 52 times 4, that is 208. And 2 plus 208 will be equal to 210. So as you notice, we have there the same value of remainder, which is 210. Thus, the remainder of p of x is equal to x raised to 4 minus 3x squared plus 2 divided by x minus 4 is 210. Aside of using remainder theorem and synthetic division, we can also get the remainder by using the long division of polynomials. Since we're already done with the remainder theorem, now let's move on with the second theorem, which is factor theorem. The factor theorem states that the polynomial p of x has x minus r as a factor if and only if p of r is equal to 0. Proof. There are two parts of the proof of the factor theorem, namely given a polynomial p of x. Number 1, if x minus r is a factor of p of x, then we can say that p of r is equal to 0. And if p of r is equal to 0, then we can say that x minus r is a factor of p of x. And now let us have the examples. Show that x minus 1 is a factor of 3x raised to 3 minus 8x squared plus 3x plus 2. So using remainder theorem, let us get first the value of r, which is x minus 1 will be equal to 0, which will be x is equal to 1. Since we have already the value of r, we can substitute it to the p of x or dividend and replace the x's by 1. So that will be p of 1 equal to 3 times 1 raised to 3 minus 8 times 1 raised to 2 plus 3 times 1 plus 2. Simplifying 1 raised to 3, that will be 1. 1 raised to 2, that will be 1 also. And 3 times 1 is 3. Then, 3 times 1 is 3. 8 times 1 rather is 8. But we have here negative, that would be negative 8. Then 3 minus 8, that is negative 5. Plus 3, that is negative 2. Plus 2, that will be equal to 0. So as you notice, we have here a remainder which is equal to 0. Now, we can see that x minus 1 is a factor of 3x raised to 3 minus 8x squared plus 3x plus 2. For our second example, is x plus 4 is a factor of x raised to 4 plus 3x raised to 3 minus 4x squared. Using remainder theorem, let us find the value of r, which is x plus 4 is equal to 0, which means x will be equal to negative 4. Since we already have the value of our x, we can substitute it to our dividend p of x is equal to x raised to 4 plus 3x raised to 3 minus 4x squared. As we substitute the values, that would be p of negative 4 equal to negative 4 raised to 4 plus 3 times negative 4 raised to 3 minus 4 times negative 4 raised to 2, which, as we simplify, has a value of 256. 3 times negative 64 minus 4 times 16. And 3 times negative 64 is equal to 192, while 4 times 16 is equal to 64. 256 minus 192 minus 64, that will be equal to 0. So, from there, since our remainder is equal to 0, we can say that x plus 4 is a factor of the dividend x raised to 4 plus 3x raised to 3 minus 4x squared. Since we are done with our discussion, now let's have our activity. In this activity, find for the remainder when, number 1, p of x is equal to 2x raised to 3 minus 5x squared plus 3x plus 7 if x minus 2. Then, number 2, p of x is equal to x raised to 4 minus 10x squared minus 2x plus 4 if x is plus 3. Then, number 3, show that x plus 2 is a factor of x raised to 3 plus 7x squared plus 9x minus 2. And that's all for today. I hope you learned something. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Thank you for watching!